Hi everyone. So today we will look at the first chapter of Python materials, which is Python variables and data types. So today we will understand the logic and the core concept, like what exactly Python variables are and what in reality Python data types mean. Rather than looking at a raw code, okay, we will understand it through visual graphics, okay, so that we can understand the logic behind these concepts. So let's proceed. So the first thing we have on the screen is variables, data types, and Python. So if you see over here, we have variables. So what is a variable? So a variable is simply a secure place in the computer memory where we save information. Instead of memorizing a random digital location, we give it a human readable name so we can find it again. So what does this mean? Like it's imagine think of it as a like a safe box where in the computer memory where you can save your information, and you don't have to like remember the physical location of this safe box. You just simply give it a name like A, B, or C, okay, and you can then refer it through that name. Okay, now let's proceed to data types. So what are data types? So computers cannot inherently tell the difference between a math equation and a word written. Like what does this mean? Like a computer cannot tell like if a 42 is a text or a number, or this text is like a string or a number. Okay, so in order to like make sure like the computer understands it, we divide these into various strict categories that tells the computer like what kind of info it is looking at. Okay, like here the 42 is an int type, okay, text is a string type, so we divide it into these categories. Okay, next comes like the grammar of the machine. So what does this mean? These two tools allow you to safely store user input, clean up messy data, and calculate complex logic without crashing the system. So what does this mean? Like these two tools like variables and data types helps you to like store any input given by the user, or clean up messy data like in spreadsheets, in databases. Okay, you can clean it up, and then you can do complex calculations without crashing your systems. Okay, and these are the tools, okay, which are like used behind Netflix, Spotify, and at NASA and various research facilities, and in our like day-to-day tools also, like mobile phones, laptops. Okay, so now let's proceed ahead to the next slide. So before we deep dive into the concepts, here we have like some terminologies which we have to go through. So let's go through the first variable. So what is a variable? A variable is a named container in a computer memory used to store a specific piece of information. Okay, so think of it like it's like a box, okay, in which you can like store a specific piece of information. Okay, now let's proceed to interpreter. So what is an interpreter? So as you know, like we write program in English language, right? But computer understands binary language like ones and zeros. Okay, so what interpreter does, it translates your code from top to bottom into like from English into that machine language, one and zero. Okay, so that's what is written over here. Python built-in translator that reads code top to bottom, turning English like commands into computer actions. Next, let's move on to the assignment operator. So what is an assignment operator? It's a single is equal to symbol. So for what it is used? So it is used to store information which is on the right side of this is equal to. into the variable that is on the left side. Okay. After that we have string. So string is basically a data type used to store text data in Python. Okay. And it is wrapped in quotation marks. Okay. Like it could be single quote or double quotes. Okay. Within that, whatever comes, that data type, okay, is a string. Okay. Integer. So integer is a data type used to store clean whole mathematical number without any decimal points. Example 5 or -3. Okay. What is a float now? So float is a data type which is used to store a decimal point number. Like if you have decimal points, okay, that you have to store in a float type. Okay. Next, what is a method? Okay. So method is like a built-in action in Python, okay, that directly operates on a piece of data in order to change it, or like change the format of like how it looks. Okay. After that we have concatenation. So what is concatenation? The act of linking two or more strings of text together into one longer string. So what does it mean? Suppose you have a first name and you have a last name and you want to combine those two. So you will use concatenation to combine those two so that you can get the full name. Okay. After that we have typecasting. So what is typecasting? The act of forcing data to translate from one category to another. This simply means like using typecasting you can convert a variable from one data type to another data type. Like you can convert int to a float, or you can convert a text to an int. Okay. So that is what typecasting means. What is a comment? It's a human to human note written in the code that the computer is forced to completely ignore. So in simple terms it means like it's just for human understanding, like what the code does. Okay. If we write some words in plain, some sentences in plain English, so that another developer or another human can understand what that code is doing. Okay. And the computer actually ignores these comments. Okay. It doesn't run these comments. So now let's proceed to the next slide. So now we will like first go through these variables, okay, and their execution. So first we will try to understand visually what is a variable. Okay. So here it mentions like imagine moving to a new apartment. Okay. When you pack your novels into an empty box. Okay. So here we have this box, okay, in which we have put our novels. You write books on the outside. So here we have given it a label. Okay. Sticker. Okay. We have written books over there. Later, you don't tear apart the whole apartment. You simply look at the labeled box. Okay. So what does it mean? So first you took a container. Okay. You store like whatever is needed over there, and then you assigned it a label box. Okay. Then you move to your new appointment. Okay. And you don't just randomly search each box to find your novels. Okay. You know, like I have like put my books into a box. Okay. Which is like which has a sticker over it known called books. So you just simply search for that box, and once you find that box, okay, then that's where you will see all your novels over there. Okay. So this labeling, okay, given to a container is what we call a variable. Okay. So here it's written the programming reality. A variable is exactly like the labeled cardboard box. It stores information in the computer's vast memory under a recognizable name, so you can easily find it later. Okay. So now let's move on to the next slide. So here it says the single item rule, magical forgetful boxes. So let's go through this one. So there is one critical difference between a real cardboard box and a Python variable. Python boxes hold exactly one item at a time. Okay, so what does this mean? Like variable, okay, if you have variable, in variable, suppose you were previously having a value like 1, okay, and now you change that value to 2, so it will forget 1 and it will store the new value 2. So here they have like shown it visually. So let's see what is it. So here is our like variable box. Okay, first we were having the red book. Okay, next we place the blue book over here. Okay, so this cardboard box forget like there was the red book. Okay, and now what it only contains, it only contains the blue book. Okay, so that's what written is written over here. Place a new item into the box and the old item instantly vanishes. A variable holds exactly one value at a time. Okay, current memory. Python will always and only remember the most recent item placed inside it. Okay, now let's move on to the next slide. So here we have now the Python interpreter, which is our diligent translator. So it's written when you write code and hit run, the Python interpreter takes control. Okay, so what it does, you have typed your code in like plain English, like here print hello world. What does this translator do? Okay, it takes this word, okay, and it translates it into machine code. Okay, so here they have like explained the flow, so let's go through this one. The interpreter does exactly what you say, never what you meant to say. Okay, it cannot guess your intentions. So what does this mean? Like whatever you will type, okay, it will like just blindly follow it. It can't understand your intuition behind what you have written it. So you need to make sure that the logic you are writing, as a code, okay, that is correct. Okay, it can't guess on its own. So now here it does it from top to bottom. It acts as a diligent translator, reading your code sequentially from line word to downward. So what does it mean? First it will like go to line 1. Okay, it will read all the words in line 1. Okay, then it will move to line 2, then it will move to line 3, like this. Okay, so here we have like word by word. So it translates human readable scripts into invisible electric impulses the hardware can execute. So in simple terms, if I have to put all of this together, what it means, like you typed like print hello world over here. What the interpreter did, okay, it took this print, okay, then this parenthesis, okay, it converted all of this, okay, into a machine level language like ones and zeros, so the hardware can execute it, your computer can execute that thing. Okay, so now let's move on to the next slide. Next we move on to the assignment operator, okay, which is like filling the box. To create a variable and put the data inside it, we use the assignment operator. So on the left side, if you see, we have a label, which is our variable. Okay, and here we have the assignment operator. Okay, and on the right side we have the always the content, which is data which we want to put in the variable. Okay, so if you see the assignment operator, here they have written take what is on the right, which is this, and store it on the box, in the box on the left. So what does it mean? What is on the right, okay, which is hello Python world, store it on the left, which is message. Okay, so hello Python world will get stored into this message. Okay, the so how the execution happens, the interpreter creates a box named message. Okay, first it will create a box named message and places the text hello world inside, and places this text hello world inside it. Okay, so this one is clear. Now let's move on to the next slide. So now we have some naming rules for variables. So these are the do's and these are don'ts, okay, which we don't have to do. So variable should contain only letters, numbers, and underscores, okay. S- Spaces separate command, okay. So use snake case. So if you have like if you want to define a variable like student name, okay, so you should like separate it with an underscore instead of a space, because space will actually separate that command, okay. Okay. And you should name your variables in such a manner like they are like descriptive and as per the logic what you are trying to achieve, okay. And what you don't have to do, you don't have to include any special characters like at the rate, hash, or dollar symbols in variable naming. If you want to like give a name, okay, make sure the variable name does not have any spaces in between. This is strictly forbidden, okay. And your variable name should not start with a number, and you should not give terrible variable names, okay. Although this is valid, but it's terrible because through this variable name like the user can't understand, or the developer who is looking at your code can't understand what this variable means, okay. So make sure to give descriptive names. Next we will go through the tracing of like how variables actually work, okay. So here we have four columns. First one is code input, what the interpreter does, okay, how it's stored in memory, okay, and what we see on the screen, okay. So first we like we wrote message is equal to hello python world. So interpreter what it did, it created a memory location, okay. So how it did that, so inside the memory it created a container known as message. Within that it put whatever is on the right into this message, so that was hello python world, okay. And since only memory is allocated as of now, so we didn't see anything on the screen output. Next we type the command print message. So what python did, okay, it went into this message container, it saw what is inside this message container. So it was hello python world, and it just printed this exact same text into your screen, hello python world, okay. After this, what we did, we changed the message to this hello Python crash cold course world. Okay. So now what the interpreter did, it discarded this old value, hello Python world, and it assigned this new value into the message. Okay. So if you say it assigned this one, hello Python crash course world. Okay. And now after that we printed like print message. So Python looks up message, and then it found this new what we have defined over here, okay, and it printed that same exact literal string onto the screen. So it printed hello python crash course world, okay. So that's what it looks like. So now let's move on to the next slide. So error remediation, name error. So what it means, okay, like over here if you see we defined a variable message with double s, okay. But if in the print, okay, you print it with a single s, okay, it will say, it will give you a name error and it will say message is not defined. So the root cause it, you created a variable labeled message with double s, but ask Python to print message with a single S. Okay. Computers are unforgivably literal and search memory exactly. So it can't like guess like this message by this single S message you mean this variable. It can't literally do that. Okay. So you need to make sure like the whatever variable name you are assigning, that same variable name you are using in your print statement, okay, and elsewhere in your program. So That's what this slide says. So now let's move on to the next slide. So now we have over here canvas 2, which is strings and formatting. So we have to like understand it through this bracelet analogy. So it's written over here, think of text in Python as a charm bracelet. Okay, each character, letter, space, comma is a charm strung in a very specific order. So if you see over here this hello, okay, consider it is this charm, okay, then E is this charm, L is this charm, okay. So that's how like all this is strung together, okay, okay, in a very specific order, okay. So after that what we have, the quotation marks, which is like over here, if you see, this is the quotation marks, okay. Quotation marks around your text are simply the claps at the end of the bracelet. They tell Python exactly where the jewelry begins and ends. So what does it mean? Like if you see this bracelet, okay, you know that from this claps, okay, the jewelry begins from here, okay, and it goes all the way up to this claps, okay, it ends over here, okay. So similar to this one, in Python, okay, your string starts from this quotation, okay, and it continues all the way up to this closing quotation, okay. So that's what it means, okay. After that, let's move on to this next slide, okay. Now here it mentioned like what is a string. So a string is Python official data type for handling text, okay. So you can either like put it in double quotes, okay, or in single quote, okay. The rule of quotes. Now we have to like be careful over here. Anything wrapped in quotes is treated strictly as text. Even if you put 1 2 3, which is a number within like these quotes, okay, it will be seen as a text word and not a mathematical number, which means it will be stored by the Python as a string rather than as an int, okay. So now flexible caps. So Python is accommodating. You can use single quotes or double quotes. Both work perfectly. What does it mean? You can use you can use single quotes or you can use double quotes. Okay. The only thing you have to take care, like whichever quote you are starting it, you have to end with that same quote. Okay. You can't do like you started with like a double quote and you ended with a single quote. That will like cause crash, okay. The interpreter will throw you an error. So now let's move on to the next slide. Now we have some string methods, which is like giving instructions to the data. Methods are built-in actions accessed by a dot. So you access what is a method? It is a built-in action, like it's already like defined in Python, okay, and you access it through a dot, okay, an action name, which is this, and a parenthesis, okay. So it is like giving a specific instruction to the data itself, polishing the charms. So what does this whole line mean? Like you access a method through three things, okay. First is the dot, second is the name of the method, and third is this parenthesis for calling it, okay. And this is like this combined whole thing is like you are giving some specific instructions to the data, okay. So if you see over here we have this raw string Ada Lovelace, okay. If we use dot title, so what it does, capitalizes the first word of every word. So what will it do? It will capitalize this first A and this first L, okay, of the word, like the starting word, okay, starting character of the word. So here you see it's Ada Lovelace. Upper will capitalize everything. So you see, so it does that. dot lower you have now, so it will like convert all of the input text into lowercase. Okay, so that is what it is. Okay, so you then you can do like print student name dot title, so you will get this output, Ada Lovelace in title case. Next we move on to the concatenation, so which is like linking bracelets together. So using the plus symbol, okay, which is this symbol, okay, to merge two or more strings into one continuous string. Okay, so what does it mean? You using this plus symbol, you can combine this first name, this single blank space, okay, and this last name into one combined string, which is full name. Okay, so here we have a literal trap. Python merges exactly what you tell it. So what does it mean? If you like do this Ada plus Lovelace, it will not put a space by default. It will just squash these two, okay, strings into each other. Okay, so the solution is you must explicitly add a literal string, which is this single space in the middle, to make it readable. So the example will be first name plus this within double quotes you have a single space and plus this last name. Then you will get Ada space Lovelace. Okay. Now we come to white space characters, which is invisible formatting marks. White space refers to any non-printing character, like which isn't visible on your screen. Okay. Python uses these combinations inside strings to generate these marks. Okay, so you have two of them. One is slash n, one is slash t. So slash n forces the text to drop down exactly like hitting the enter key. So when you put what it will do, okay, so what it will do, like here if you see we have languages, after colon we have slash n. So whatever is there after slash n, that will go to the new line. So if you see here, it has moved to the new line. Okay, now let's see what is slash t. So it creates a wide gap, pushing text to the right, useful for indenting lists. So it's like slash t is if you are trying to give a tab. Okay, so if you see over here, after next line, I typed like slash t. So it exactly like gave a single tab and pushed everything to the right. Okay. So you have Python. After that, again, we put slash n. So it moved to the next line. Then we gave slash t. It gave a tab. Okay. Pushed to the right and we typed JavaScript. Okay. So this is what we see in the console. Okay. Language is Python, JavaScript. Okay, now let's move on to the next slide. Next slide is stripping white spaces, scissors for invisible spaces. If a user hits spacebar after typing, Python sees username with a space. Okay, so what does it mean? Okay, like you defined like a variable name, or you put something in the quotes. Okay, not a variable, like you put something in the quote like username, but accidentally you typed a single space. Okay, so Python, what it will think, like you mean the text username along with this space. Okay, so what it does, okay, extra spaces ruin your data, because now when you will try to like access username, it can't find it, because your this thing is stored as username along with this single space. Okay, so that will like ruin your data. Okay, so Python provides like three methods to like clean these blank spaces. Okay, so first one is lstrip. Lstrip is cuts extra spaces off the left end. So what does lstrip do? If you have some extra spaces on the left, okay, it will like remove those spaces. Then you have strip. What it does, okay, it cuts the spaces of both sides at once. So what does it mean? Like strip, what it will do, it will like remove all the spaces from the left side, from the right side. But if you have any space in between the words, okay, like in between the words, it will keep those spaces, it won't remove the spaces between the words. Okay. Then you have R strip. So what R strip does, it cuts extra spaces of the right hand. So whatever spaces you will have on the right side, if you apply R strip, okay, it will remove those extra spaces on the right. So here we have like this one, okay, formatting messy data. Okay, so here we have this code, first name Ada, okay, then last name Ada Lovelace. So in the memory, how it's stored, we have a variable created like a container in which Ada is stored. Then we have a last name container that is created in which Lovelace is stored. So here it's written like two variables hold purely lowercase strings. Okay, then you did this. Full name is equal to first name plus a space within double quotes plus last name. So right side evaluates to Ada Lovelace. The box full names hold this combined value. So here if you see, we got a new container created full name which has this like complete string Ada space Lovelace. Okay. Next we printed like and in both these scenarios, since we didn't use print statement, okay, you see there is nothing which is printed on our screen. Okay. After that, in this last statement, we printed hello, then space, comma, and space plus full name dot title plus an exclamation sign. So how it does that? So first it prints like hello, comma, and this exact space. After that, we have a plus and full name. So what is this full name? Ada Lovelace. And we applied the title method. So it will capitalize this first word over here, first character over here, A, and this L character over here. So it will become Ada Lovelace. Okay. So Ada Lovelace, okay, will be there. And then after that, we will have an explanation sign. Okay. So here that's what is written like dot title filter transforms it in memory to Ada Lovelace. So in the memory itself, in the full name, okay, it gets like changed to Ada and then Lovelace. Okay, like first word gets capitalized in the memory itself. So now let's look at another like error remediation which is very important to look. Okay, so suppose you have a message like it starts with a single quote, one of Python's strengths. Okay, so as I told you, like whatever is between the quote, it will treat it as a string. Okay, so over here if you see, it started with this single quote. After that it saw this single quote, so it thought, okay, the string is up to here only and it ended over here. So now it's wondering what is this one. Okay, so that's why it threw this error, syntax error, invalid syntax. So what is the root cause? You use single quotes to collapse the string. Message is equal to one of Python's. Python hits the apostrophe inside Python's, okay, strictly assuming like it is the ending collapse, like where your string ends, and panics at leftover h strings. So it didn't know like what is this one. Okay, so how you can fix it? You use like, if you know like within your like text what you are defining, okay, on the right side if you have a single quote, always like start with the double quote, put everything in the double quote. So if you see, okay, instead of starting with single quote, we started with double quote. Put your message over here, like here you see we have a this single quote also now, and we ended with double quote. So this one, now what will Python read it as? It will read all of this as a complete text. Okay, yeah, so it won't like throw any syntax error. Next, move to like the canvas 3, which is numbers and typecasting. So here you see the conceptual anchor, calculator versus the label marker. So here we have calculator, here we have label marker. So what is the calculator? Understand deep mathematics, you punch in numbers to evaluate logic. So you type like 2 plus 2 and calculator gives you the answers. Okay, so that is what calculator does. Okay, now what the label marker does, it prints exact text triggers. Okay, so whatever label is over here, okay, it will exactly print that. Okay, feed it an equation, it just prints literal symbols without solving it. So if we like give it like over here label, okay, we have like 2 plus 2 is equal to this symbol. Okay, it will print it as it is without solving it, whereas calculator solves it. Okay, so what is the bridge? You cannot show a text sticker into a calculator circuitry. You must actively translate between the two using typecasting. Okay, so what does this mean? Okay, in order like for if you want to solve this, okay, you have to change the type from this text label marker to the calculator, then only this equation will get solved. Okay, so this same analogy gets applied to this typecasting of variables. So let's see into that. So here if you see, we have integers and floats. Okay, Python acts as our calculator, neither type uses quotation marks. Okay, so here you see we have integers which are clean whole numbers without decimal points. So here are some examples: 5 minus 3 and this number. Okay, so it's fast and precise. You will type 2 plus 3. Okay, you type enter, you will get 5. You type 2 star 3 on console, you type enter, you will get 6. You type 3 double star 2, okay, which is like exponential. Okay, so it will do 3 square, so you will get 9. Okay, and in float, okay, any number with a decimal point, it could be 1.5, it could be 3.14. Okay, the decimal can float to any position. Okay, so you can store any number of uh, numbers, okay, after the decimal point inside the float. Okay, so here you see we have 0 0.1 plus 0 0.1, you will get 0 0.2. Okay, and similarly if you type 0 0.2 plus 0 0.2, we will get 0 0.4. So here is a note. Okay, translating decimals to binary ones and zeros sometimes creates endless fractions. 0.2 plus 0.1 might output 0.30000, these many zeros and then 4. This is normal across programming language, and this is one of the questions, okay, that is actually asked. Okay, so what does this mean? Okay, like the interviewer can ask you like what output I will get if I type 0 0.2 plus 0 0.1. Okay, so he's expecting you that you should know like Python actually converts 0.2 to binary, 0.1 to binary. Okay, and then adds them in the binary and then convert it back to the float and give you the answer. So that's why the answer you will get, it will not be strictly 0.3, you will get these many decimal places. Okay, and some number at the last. Okay, after the decimal. Okay, so this is what happens. Okay, after that, now we have typecasting with string. Okay, to print a mathematical number nicely inside a text sentence, run it through a translator that turns the math object into a text sticker. So what it does, okay, suppose you are trying to print a number on a string along with the message. Okay, so if you just directly try to combine those two, okay, it will throw you an error. Okay, so you will put that number within this string function. Okay, and that will store it as a text. So here if you see this machine, okay, here we have 23 as a number, and here we have this string function. Okay, so what it does, it will convert this 23 as an int number to 23 as a text. Okay, so it will be stored as a string. Okay, so the function, we do this using string function. Okay, str function mechanism, wrapping a number variable inside str forces Python to momentarily ignore the math and convert the value into string characters so it concatenates safely. So if you apply string to a number, okay, this number, so it will convert it to a text. Okay, so this over here is a text, here 2 is a character, okay, 3 is a character, it's no longer a number. Okay, it's a text. Next we move on to the uh, trace of it, like how it does that. Okay, so first we have this variable age is equal to 23, so 23, okay, gets stored in this age variable, so that's what is written over here. Memory translation, box age holds the mathematical integer 23, okay, without any quotes, so it's stored as an integer. Okay, after that we didn't have any printed. Okay, so nothing is on the console yet. So now what we did, okay, we printed like message is equal to happy plus string of age plus rd birthday. Why this string of age is needed? Because if you try to concatenate a text, okay, a string with a number directly, it will throw you an error. Okay, so that's why you have to typecast it, you have to convert the number to a string. Okay, so string of age translates math object 23 into text ticker 23, which is this stored as a text now. The bracelets link, so how they link, happy plus 23 as a text, okay, plus rd plus birthday, and then if you print message, okay, you will get this. Python seamlessly outputs what it outputs, happy 23rd birthday. Okay, now let's move on to this one. Okay, so here is that what I told you. Okay, if you directly try to like do happy, which is a string, okay, and age, which was having a number variable, okay, it will throw this error, can't convert int object to string implicitly, means it cannot do it like on its own. Okay, you have to specifically mention like str of age, then only it can do that. So what is the root cause? Python is strongly typed. It looks at the text needless on the left and the math object to the right and refuses to implicitly smash them together. Okay. So what is the fix? Okay, you put it inside this str, okay, function. Okay. So that will take care of it. Okay. There is one note over here in older Python versions, like below Python 3, okay, before Python 3, okay, like Python 2. Okay, so if you like on the console you type 3/2, okay, so it will show you output as 1. Okay, so it used to strip off the decimal place, but in Python 3 now it like correctly gives you a floating point number, so it will show you correct value as, which is 1.5. Okay, now let's move on to the this last one, okay, which is comments and the zen. So the conceptual anchor, the director commentary. Okay, so what does this mean? Analogy, let's go through the analogy. Comments are like a director commentary track. Okay, so comments are like a director, what director is saying. Okay, like he when he directs a film, okay, how he directs the team, okay, to shoot in this manner or act in this manner, okay. That's what comments are like, okay. The computer running the code, the audience doesn't hear it at all. So think of computer as an audience, okay. So you only, like when you watch a movie, okay, you will only see hear hero from like dialogues from heroes, okay, and heroines, okay. You want uh, like actually like hear what the director is saying, okay. So which means it doesn't change the plot, okay. So what is the value? It is invaluable for other program. It allows the creator to whisper behind the scenes and explain why code was written, what motivation was, and how a trick was achieved, okay. So it's like it's for the another person, okay, who is reading your code or who is debugging your code, okay, so that he can understand like what your code is actually doing, how it is doing, okay. So that is why comments are necessary. So now let's move on to the next slide. So the invisibility cloak and the zen. So how you write it? You start with the hash mark symbol, okay. So anything typed after this hash mark, okay, on a line, like anything typed on after this hash symbol on this line, okay, will be completely ignored by the interpreter, okay. So no memory will be used. So if you see this one, okay, if you have written this code like this hash say hello to python and print hello world, so what python will actually print on the console is simply hello python people, okay. It will not print this one, okay, because this is a comment, okay. It's just for your understanding and other people understanding, okay. Python literally doesn't see that. It simply ignores everything which like starts with the hash symbol, okay, on that line. So now here is a tip, okay. So simple is better than complex. Don't write a 10 line labyrinth if a 2 line solution exists, okay. Make it easy on the eyes, okay. Readability counts. So what does this mean, okay? Like instead of writing a very complex logic, okay, try to like first solve the problem using a simple logic, okay. So and make sure your code is readable. It shouldn't be that much complex like nobody is able to read it, okay. So it should be readable. Next, now let's move on to the next slide. So we have this code trace documenting the intent. So we will go through this trace, okay. So first we have this hash symbol. Python sees the hash, it immediately stops reading, jumps to the next line. Text remains invisible to the machine, okay. So the moment Python sees this hash, okay, it completely ignores this, it moves to the next line, okay. So what it sees in the next line, print welcome back user, okay. So Python will execute this command. So what will Python print? The program outputs what it will print, okay, welcome back user. So the descriptive note lives safely inside the source file for human eyes only. So this comment is only for the human to read, okay. Python completely ignores it. It doesn't seize this one. Okay. So now let's move on to the next slide. So error remediation. Okay, the comment road, the danger of lying code. Okay. So here you see if a comment says add 5 to the total, but the code beneath it says total is equal to total star 10. So what does it mean? Okay, it means like you changed your code but you didn't updated your comment. So another person who will be looking at your code, he will like say, okay, no, your logic is wrong because you have mentioned in the comment, okay, like 5 should be added to the total, but you actually did like multiplied the total by 10, okay. So you need to make sure like whenever you are changing your code, okay, your comment should align with that code, okay. And write comments that explain why you are doing, not what you are doing, okay. The Python syntax already shows the what. Okay, so the comment should focus on the why of that logic instead of what, because what you are already coding. Okay, you have already written code for that, so you have to just uh, write the comment which explains the why behind that logic. Okay, so that is the thing. So now let's move on to the next slide. Okay, so here we have like this same mathematical data, numbers and textual data as a string. Okay, so the same example which we saw previously. Okay, rule of this uh, numbers and string. Okay, which we saw in the typecasting. Okay, so now let's move on to the next string. Okay, it's again the same. Okay, we have, okay, and here is this example which I told you. Okay, like on the terminal you typed 0 plus zero point 0.2 plus zero point 0.1, you will get these many numbers, decimal places, and after that you will get a 4. Okay, so what is the why does the computer translate base and decimal into binary base 2? Okay, so that's why like you end up having these many fractions. Okay, these many decimal places. Okay, so here now I have a table. Okay, in which every operation is defined. Okay, so if you do addition, okay, you will get data output as an integer. If you do subtraction, okay, of like integers, okay, you will get output as an integer. If you do multiplication, you will get an integer. But the moment you do the division, okay, even though it's a clean division, okay, you will get a float. Okay, and in order to like if you want like you get an integer, okay, you have to put double slash. Okay, then only it will just return the quotient as an integer. Okay, after that we have exponent. So if you give 2 star star 3, it's 2 to the power 3, which is 2 cube, so which is 8, you will get an integer. So this division is written like if you give a single forward slash, you will always get a floating number. Okay, so this is what we have already seen. Okay, okay, again it's the same thing. Okay, and these again like are the same. Okay, old Python version. Okay, these comment. Okay, again it's the same thing we have seen. Okay, okay, and this is for the comments. Okay, and this like simpler is better than complex, and the readability counts. Okay, so again it's the same thing, and this is the comment route we have already seen. Okay, and this is like a uh, flow of what we have covered today. We covered variable assignment, we covered typecasting, string formatting. Okay, clean documentation, which is like the comment. Okay, okay, and on top of it all of this is built. Okay, and this is a summary of everything like keynotes what we covered in this section. So we covered like variables, okay, which are single item memory boxes. Python only remembers the most recent assignment. Okay, you should use snake case. Okay, strings are then sequence of characters clamped by quotes. Methods we apply over that. Okay, some of those are like dot title, dot lower, and dot strip. Okay, numbers we have like integer and float data types. Okay, and for typecasting we use string. Okay, then we have like come for comments we start with the hash symbol. Okay, and after that we should take in mind like readability counts, so simpler is always better than complex. So that's it for this presentation. Thank you.